So less energy available and more energy demand, two things are going to happen. One of them is we're going to have to adapt data center to new forms of energy, namely renewable energy. What this means exactly, we're working on it. I mean, it's a big challenge right now. The cost of energy is going to soar also as it becomes less and less available. For one thing, we have to adapt to new forms of energy, and the other thing we have to do is learn to minimize the use. And this is one place we're focusing right now. Traditionally, there's a KPI that's in the last, I would say, 5 to 10 years, as data centers, became more and more prominent around the world. The need to reduce energy became felt, so the industry came up with this key performance indicator, which is a PUE, which stands for Power Usage Effectiveness. So it's how well we use the power. And it helped a lot, and it's been used in order to gauge how well a facility is doing, but it's not a very accurate term. It looks at the entire infrastructure of the facility, basically. It was good for a while, but now we have to start breaking it down, and this is a challenge we're working on right now. Basically, we start to look at the efficiency of the equipment inside the facility, the servers, the storage, how much work can they produce versus the energy that they're using. So that's one thing. The other thing is cooling is a big challenge, because all this power that's being dissipated through the equipment, I mean, there's losses that go out in heat, and so we have to exhaust that heat from the facility, otherwise it's going to get too hot. There's new technologies emerging as far as cooling technologies. There's airflow management. There's different methods of optimizing the way the heat is being removed. The traditional methods, basically looked at the technology always. But again, the technology can't change as fast as the demand for more cooling, so we're basically now trying to use all of this new data that's made available in order to look at the bigger picture. Maybe the geographical position of the facilities can be optimized. Maybe water will become a common means of cooling, so we're going to start placing facilities near water sources. Also, we're starting to look into things like how efficient the cooling is versus air density. So if a head end is at the higher elevation, maybe it's more difficult to cool. Also, how readily available is the energy? Is there renewable sources of energy in the geographical location where we want to place a facility? So all these things are becoming available now, like the data, so we can start correlating what really impacts the energy consumption besides just the equipment inside.